Okay, this next video will be just page 2 of the packet. You have 3 more definitions. Electronegativity, and you need to know electronegativity in order to do the next packet, understand it. So that's the most important one. So, like I said, ionization energy from video number 1, and electronegativity are 2 tough definitions. All right, and then malleable and ductile are pretty easy. But we're going to spend most of this video on electronegativity. Okay, electronegativity is right next to the first ionization energy on table S. Let me give you a definition. Electronegativity is, I'm going to write this for number 1, the ability or tendency of an atom to gain an electron or attract an electron. The ability or tendency of an atom to gain an electron or attract an electron. And for number 2, just write an atom's attraction for electrons. An atom's attraction for electrons. Okay? All right. So, some examples. Let's go up to the first couple elements. All right. For example, sodium. Electronegativity values are just like grade point average. It runs from 0 up to 4.0. Usually anything above 3.0 is considered very high electronegativity. All right. Remember, electronegativity's ability to gain electrons. So fluorine has the highest electronegativity of them all, 4.0. So fluorine has the greatest ability to gain electrons than any other atom. They really want to snatch electrons from other atoms right away. Sodium, on the other hand, has a very low electronegativity, 0.9. They don't want to gain electrons. They want to lose electrons, as you learn in the next video. All right. But so if you have a high electronegativity, that means they have a good ability to gain electrons. They really want to gain electrons. If you have a low electronegativity, it means they don't have any ability to gain electrons. They really want to lose electrons. All right. So. Now let me demonstrate. First, I'm going to demonstrate an atom with a low electronegativity like sodium. All right. So we'll pretend I'm sodium. I'm a sodium atom. Electron's going to come flying by me, and I'm going to push it out of the way because I don't want to gain electrons. I have a low electronegativity. So here we go. Get that out of my face. Get that out of my face. Okay. Now I'm going to be fluorine. Fluorine has a high electronegativity. They want to gain electrons. Fluorine really wants to gain electrons. So here we go. I want you right now, baby. Gotta have you. Gotta have you right now, baby. All right, so you get that? So, low electronegativity, I don't want you. Get out of my face. High electronegativity, I want to gain electrons. So now pause the video and answer questions 1 through 8. Question 1. Electronegativity is a measure of the atom's ability to, let's look for definition. Choice 1 is correct. Attract the electrons in a bond between the atom and another atom. Okay, question 2. An atom of which element has the greatest attraction for the electrons in a bond with a hydrogen atom? Alright, so that's why I have no definition, because if you don't know what greatest attraction for electrons means, then you're not going to get the question. You have to memorize the definitions. So greatest attraction for electrons means greatest electronegativity. So we look up all 4 choices on table S, and we pick the greatest attraction for electrons, which is the greatest or the highest electronegativity. All right, so choice 1 is chlorine, at 3.2. So again, on the reagents and tests, I write it next to the answer choice. Phosphorus has electronegativity of 2.2. Silicon, 1.9. And choice 4, sulfur, 2.6. So the greatest attraction for electrons, greatest electronegativity is choice 1, chlorine. Okay? And the same rule applies for all the rest of the questions on the page. Number 3, which element has atoms with the greatest attraction for electrons in a chemical bond? It's going to be choice 2, fluorine, which is the highest of any element, 4.0. Number 4, the ability of a carbon to attract electrons is going to be choice 4, less than that of nitrogen and oxygen. Okay? So let's go there. Carbon 2.6, it's less than 3.0 of nitrogen and 3.4 of oxygen, so it's choice 4. The ability of carbon to attract electrons is choice 4, less than that of nitrogen and oxygen. Number 5, which element has an atom with the greatest tendency to attract electrons, which means greatest electronegativity in a chemical bond. Look them up, pick the highest one as choice 2, chlorine. Question 6, which element has an atom with the greatest attraction for electrons in a chemical bond? Again, greatest electronegativity, the answer is choice 3, N. Number 7, which term indicates how strong an atom attracts the electrons in a chemical bond? That's the definition of choice 3, electronegativity. And question 8, an atom, which element has the greatest attraction for electrons in a chemical bond? Look for the greatest electronegativity. This time it's choice 4, Se. Okay. Now the last two definitions on the bottom page, don't have any questions on them, just you have to know the definitions. All right. Next word is malleable. What does the beginning of the word malleable look like? It looks like the word mallet. What is a mallet? Mallet is a type of hammer. All right, so if you look at this filing cabinet was hammered into sheets, right? So some elements you can hammer it into sheets, like sheet metal, okay? So this filing cabinet was hammered into sheets. So this filing cabinet is made out of something that is malleable. So next to the word malleable, write the ability to be hammered into sheets. The ability to be hammered into sheets. That's the definition for malleable. The ability to be hammered into sheets. And the final word is ductile. It comes from the word, think of conducting electricity. What conducts electricity? Wires. So the word ductile means the ability to be made into wires. The ability to be made into wires. Write that down. The ability to be made into wires. All right? And you can learn later on what elements are malleable and ductile, which elements are not malleable and ductile. Okay, this concludes our page 2 video.